Hey, welcome back to Algebra 2. Today's lesson is 9.1, which is the first lesson in our unit on trig. So today we're talking about rotations and angle terminology. So in this unit, we're talking about the three basic trig functions that are going to be sine, cosine, and tangent, which you should be familiar with from geometry. So we're going to do a quick review, and then we're gonna dive into some more applications of those. So all of these functions are called the circular trigonometric functions, circular functions, because they're based on the geometry of a circle. Um, so we're gonna go over what we call different parts of these angles so that we can talk more accurately about them before we talk more about trig. Okay, so standard position is any angle where the initial ray, which I'm going to do in purple here, because purple is my favorite color, is drawn on the positive x-axis. So this angle that we have here has an initial ray on the positive x-axis, which means that it's in standard position. Okay, from there, you can rotate to get to the terminal ray either positive or negative. A positive rotation is going to be counterclockwise this way. And a negative rotation is going to be clockwise this way. This might seem a little bit unintuitive, but it's just what everyone agreed on, and so we stick with it. All right, two angles are coterminal, and the terminal ray is going to be the other half of the angle. So the terminal is going to be this green one. Two angles are coterminal if their initial and terminal rays are the same. So what that means for us is this yellow angle here is coterminal with, let's find a new color, orange angle over here. Because the initial ray for the yellow angle is going to be that one on the x-axis is going to be the purple one, and the terminal ray is going to be the green one. And for the orange angle, same thing. We have the initial ray is the purple, and the terminal ray is the green. So because these have the same initial and terminal rays, we call them coterminal. All right, and then we have reference angles. A reference angle is, the definition is a positive acute angle formed by the terminal ray on the x-axis. All right, so I'm going to do a little bit of erasing because this got pretty cluttered pretty quickly. Eraser. It's just red pen. There we go. All right. So we need a positive acute angle formed by the terminal ray and the x-axis. All right, well, it can't be this yellow thing because that's not acute, it's obtuse. So we're going to need, it's going to wind up being this angle right here. Because it's acute, it's less than 90 degrees. It's positive because it's in the positive direction. So we're talking about this measurement here. And it's between the green terminal ray and the x-axis. So if we move this one over so that it's moving positive and that it's in standard position, we're going to wind up with something like this angle, which I guess we can call R for reference. All right. So make sure you have all this down. You don't have to copy down the whole picture. Just make sure you understand what all these different terms mean. If the picture helps you, feel free. All right, so moving on to exercise 1, we have, okay, for each of the following angles given by the Greek letter theta, draw a rotation diagram and identify the quadrant that the terminal ray falls in. All right, so we refer to angles usually by theta, which this may be familiar from geometry. It looks like a 0 with a horizontal line through it. Generally speaking, we use, when we're labeling a geometric figure, we use little lowercase letters for edges, capital letters for points, and Greek letters for angles, just so we can keep everything all separate. That's how we use that. Anyway, all right, so let's do number A. Letter A. All right, so we have a positive number. So we're always going to start at the positive x-axis, because that's always going to be our, it's always going to be how we draw things that are in standard position. We always need our initial ray to be on the positive x-axis. Okay. Then we're going 145 degrees in the positive direction, which means counterclockwise. All right, so if we go first 90 degrees, we get to here. And then we're going to go 55 degrees further than that, because 90 plus 55 is 145. So we're going to wind up about here, a little bit past, a little bit before 10:30, if you think about it like a clock. And this whole angle, we're going to label theta. And then we're all set. And what quadrant is this? First quadrant, second quadrant, third quadrant, fourth quadrant. So we're going to be in the second quadrant. All right, let's do B. Okay. So initial ray, always going to be on the positive x-axis. So we're still going positive, so we're still going to be rotating counterclockwise. So in this time we're going, all right, so if we go 90, 180, 270, still going. 270 is going to be 50 degrees past 270, which is going to be like a little bit past, a little bit before 430. So it's going to be something like that. And then this angle here is going to be theta. And normally when you have an angle that's larger than 180, you want to just make sure with this little Pac-Man circle to say which side it is, so we're not talking about this angle here. All right, C. Here we have 72. So initial ray, always going to be on our positive x-axis, and then we're going to go 72 degrees up, which is going to be maybe like 130. Something like that. Here's theta. Oh, sorry, quadrants. This is quadrant 1. This is quadrant 4. Scatterbrain. All right. Initial ray, positive x-axis. This time we're going negative, which means that we're going to be going clockwise. So you got to be careful. You got to watch your signs. So we go 90 degrees clockwise. We go 180 degrees clockwise, and then we go 30 degrees further. It's going to look something like that. And you get this angle theta with our little Pac-Man to say which side we're on. And this is quadrant 3. Move this down. All right, so now theta equals positive 250. So initial ray, always on the positive x-axis. We're going counterclockwise because it's a positive direction. We go 90, 180, and then we're going to go 70 degrees past that, which is going to look something like that. With our little Pac-Man. That's a terrible theta. Thetas take practice to draw. I've had plenty, and yet here we are. All right. Here we have theta equals negative 310. So we got our initial ray. And then we're going to go clockwise because we have a negative angle. We're going to go 90, 180, 270, and then 40 degrees more. Something like that. Get that angle. Now we have theta equals 460. All right, this is a weird one because this angle is more than all the way around. All right, but it's positive, and we still know that our initial ray has to be on the positive x-axis. Okay, so we go around, and we're going to be going counterclockwise because it's positive. So we go around 90, 180, 270, 360. I'm trying to think of this. 450, and then we go 10 degrees further to 460. All right, well, you might be tempted to do this angle or this angle, but neither of those is right. Instead, we have to go, because that's not what we did. We went all the way around to here. We're going to call this angle theta. We're not going to be dealing too much with angles that are larger than 360, but this is how I'd represent them. All right, and then we have H, another angle bigger than 360. So we start with our initial ray. We're going counterclockwise because it's negative, and we go negative 90, 180, 270, 360, and then another 40 degrees to here, and our spiral winds up being that. And there's our theta. Quadrants. All right, quadrant here is going to be 3, 1, 2, 4. Make sure that you understand all this, especially the angles greater than a full circle. And then we're going to move on to exercise 2. All right, exercise 2. In which quadrant would the terminal ray of an angle drawn in a center position fall if the angle measures 860 degrees? All right, well, I don't want to count by 90s up to 860, so we're going to do a trick. So I'm going to draw a picture. You always want to draw a picture with angles, anything geometry. Start off by drawing our picture. Okay, so we know our initial ray has to be here. We're trying to figure out where our terminal ray is. And we know that the angle is 860. Okay, well, 360 just means going all the way around, right? So as we saw over here, back here, the angle for this one, for our big yellow spiral, this one, falls in the same quadrant as this little angle, right? So if we subtract 360, the angle for negative 400, the quadrant for negative 400 degrees is the same as the quadrant for negative 40, because going all the way around doesn't change where you wind up. So what I'm going to say is that if we go all the way around, if we subtract 360, that doesn't change where we're going to wind up. So this is the same as 500. Okay, well, that's also more than 360, so we're going to do that again. We're going to get 360. We're going to get 140. So I'm saying that, we also need degrees. I always forget. I'm saying that our angle of 860 degrees is going to wind up in the same, it's going to be coterminal, it's that vocab word, with the angle 140 degrees. And that one we can do. Because if we just go 90 and then 50 degrees more, we're going to wind up with that. So if we wanted to draw the whole thing, well, we did 2 full circles, and then we wound up here. So that would look something like 1 full circle, 2 full circles, to here. That's kind of intense. But it does show us that we wind up in the second quadrant. And we're going to be using, this is why we don't see angles that are this big that often, because we're often going to represent them like 860 just as 140. Give a negative angle that is coterminal with each of the positive angles alpha. All right, alpha is another Greek letter. You can write it like a swirly A, or you can write it like a fish. I write it like a fish because it's easier for me. Do whatever your heart desires. All right. Give a negative angle that is coterminal with each of the following positive angles alpha. All right, so let's just draw pictures because can't go wrong with a picture. And then we're going to see how to do it algebraically. So our first one, alpha is 90 degrees. Well, that's not so hard to draw. Okay, so we need something that's coterminal with this. All right, well, that's just going to have the same initial ray and then be going the opposite direction. Because it has to be negative, because these ones are all positive. So negative is going to be to here. All right, well, how many degrees is this? It's going to be 90, 180, 270. Let's do one more. So if we draw our coordinate plane, and then we draw our initial ray, and we go around 330, so that means 90, 180, 270, and then 60 degrees further to here. So our positive angle is this. So our negative angle is going to have to be this little thing. Well, this part is 60 degrees out of 90, which means that this little red part has to be 30 degrees left. So we're going to be negative 30 degrees. forgot my negative sign in the last one. Whoops. Because remember, this one is going this way around, and the green one is going in the positive direction. I'm going to finish drawing all my arrows on. Okay. So what you might notice is that both of the magnitudes here, 90 and 270, 330 and 30, add up to be 360. And if we look at our pictures, the measures of these two angles describe a complete circle. Here we're going around from here to here, and then the rest of the way around with a negative angle. So let's see if that works with C. Many of you hint it will. All right, so we start by drawing our initial ray here. Then we go 120 degrees, which means 90 degrees up, 30 degrees over, so like that. All right. Well, what plus 120 is going to be 360? Well, 360 minus 120 equals 240. So our guess is that it's going to be equal to negative 240. And indeed, we do get 90 degrees to here. We're starting here. 90 degrees to here, 180 to here, plus 60 gets us to negative 240 degrees. All right, so if you're satisfied with that, you're welcome to use the algebra for the last one or for any of these. If you want to use the picture again, that's totally fine. Any method works. All right, so I'm just going to use the algebra on this one. So we have alpha equals 210 degrees. Well, 360 minus 210 is going to be 150. So I'm going to say that my negative angle that's coterminal with alpha is going to be negative 150 degrees. So remember, any method will work. It doesn't matter if you're using algebra. It doesn't matter if you're using a picture. It doesn't matter. However you want to do it is the right way to do it for you. There's no wrong answers here. There are wrong answers. There's no wrong methods here. All right, geometric exercise 4. All right. Coterminal angles drawn in standard position will always have measures that differ by an integer multiple of. Okay. So these ones don't seem to differ by anything in particular. But the thing that we have is the blue ones are not drawn in standard position. Oh, sorry, that's not true. Ignore me. That's not true. These are drawn in standard position. Coterminal angles drawn in standard position. What do these all differ by? The list differs by 360. It differs by 360. Differs by 360. Differs by 360. So sorry about that. And if you look up here, all these angles that we did all differ by 360. That's what we're doing over here. So coterminal angles drawn in standard position will always have measures that differ by an integer multiple of 360 degrees. Because if you think about it, going all the way around the circle isn't going to affect where you wind up. Now we have exercise 5. All right, so now we have, our last exercise is going to be about reference angles. So for each of the following angles, beta, which looks like sort of a squidgy bee with a long tail, draw a rotation diagram and then state beta's reference angle, beta little r. Okay, well we're old hats. We're old hands at, I don't want to say old hats. We're old hands at drawing rotation diagrams now, right? So we start with our initial ray, then we go over 90, over another 70, end up here. So this angle is beta. Okay, now we need to find beta r, the reference angle. Okay, so if we look back, a reference angle is the positive acute angle formed by the terminal ray and the x-axis. Okay. So we go over here. So we need an acute angle between the terminal ray and the x-axis. Okay, so this one, terminal ray, x-axis. And then we're going to find this positive acute angle, this little green thing. And if we want to write it in standard position, it's going to wind up being this thing if we just reflect it across. Okay, well, if we did 90 to get to here, then this angle is going to have to be 70, which means that this little thing is going to have to be 20 degrees. So my reference angle, beta r, equals 20 degrees. It always has to be positive, which it is. It always has to be acute, which means less than 90, which it is. And it always has to be between the terminal ray and the positive x-axis, which it is. That's how we found it. Awesome. Okay. Let's try another one. Here we have the initial ray. We're going 300 degrees in the positive direction. You wind up with 90, 180, 270, and 30 degrees further. It's going to be 30. And this whole thing is going to be beta. Okay. So we need to find the positive acute angle between our terminal ray and the x-axis. Okay. Well, 300 degrees is definitely not less than 90, so that beta definitely can't be it. Okay, so it's going to be this length. But the problem is, as we've written it, that length is negative because it's going from our initial ray clockwise. So we're going to reflect it across to get this thing. And this measurement is going to be our reference angle because it has to be positive. So what's the size of our little purple line? Well, it's going to be 90 minus 30 is going to be 60. This is going to be 60. So beta r, 60 degrees. All right, so for B we have, for C, sorry, we have beta equals 210. All right, so we start with initial ray. We go around 90, 180, 210 degrees. All right, so we need the angle between our terminal ray and the x-axis. That's going to be this little purple thing. All right. So how much is this? So we went 90, 180, and then we went 30 degrees further, so it's going to be 30 degrees. So we're going to wind up with beta r equals 30 degrees. All right, here we have 78. Well, this is actually going to be a snap because we've got initial ray, terminal ray, something up there, and this is beta. It's also beta r because the closest path between the terminal ray and the initial ray and the x-axis is just going to be the same as the angle. That's going to be convenient. I don't think it's going to happen too often because that would be too easy, but it's very nice when it does happen. All right, then we have our last four. So beta equals negative 110. Start with initial ray. We have negatives. Remember, we're going clockwise. So we go 90 and then 20 degrees further. This is 20. And if we're looking for the connection between, between our x-axis and our terminal ray, we're looking for this. That's going to be 90 minus 20 is going to be 70. So we wind up with beta r equals 70 degrees. Here we have negative 280. So we're going to go again clockwise. We go 90, 180, 270, a little bit further for 10 degrees. And hey, we wind up with another one in the first quadrant. So we're looking for that to be our reference angle, and then this whole thing around here is our beta. So we have to be a little bit careful, I guess. You can't just say that because our reference angle is not going to be negative 280 because it has to be positive, it has to be acute, and that's neither. Okay, but it is going to be our this thing. So this was 10 degrees, which means that this rest of the thing is going to have to be 80 degrees. So beta r equals 80 degrees. Now we're back to our friends. The angle's larger than 360, so we're going to go to here, see if I can count by 90s this time. So positive, so we're going in this direction. We have 90, 180, 270, 360, 450, 540, and then we're going to go 65 degrees past 540, like that. Oh boy. All right, and I'm going to draw my whole spiral like that. That's beta. Fortunately, our reference angle is much simpler. It's just going to be this thing. And if we went 65 degrees here, past, that's what we're going to have. So beta r, very long tail on that one, 65 degrees. The last one is going to be negative 410. Initial ray, negative direction, so clockwise. We're going to 360 around to here again, and then 50 more degrees. Drawing our spiral to here is going to be beta, and then beta r is going to be this thing, which is going to be 360, and then we went 50 degrees more. It's actually not a very good drawing, but this is going to be 50 degrees. So beta r equals 50 degrees. Well, drawing this picture all the time can get a little bit cumbersome, so we're actually going to come up with a set of rules that we can use to calculate reference angles a little bit quicker. So say we have just a big old coordinate plane. And you can draw this on a loose piece of paper or in the margins. It doesn't have to be as big as this one, obviously. All right, so if we have that our angle, which for now is going to be red, is in the first quadrant, Roman numeral 1. And the reference angle, beta equals beta r. Because the reference angle is just going to be the closest measurement between the terminal ray and the initial ray. That one's the easy case we talked about in, I think it was D. The other ones get a little bit more interesting. All right, so if we have a terminal ray in the second quadrant, we have this thing being our beta. Okay. Well, then our reference angle is going to be here, right? Okay, well, what is that? Well, the whole line from along the x-axis is 180 degrees. And this is going to have to be whatever's left after we take our beta out of it. So here, beta r equals 180 minus beta. All right, so I'm going to erase this so our diagram doesn't get too cluttered, although it is going to get a little bit busy. So I'm not sure I would copy down the whole thing, maybe one step at a time. All right, so if we have something in the third quadrant over here, numeral 3, our angle looks like this. Okay, well now our reference angle is going to be just this little part here, right? Okay, well what's that measurement? Well, basically, it's the difference between our angle beta, which is this whole big circle, minus the first half of the circle, right? So minus 180. So here, instead of having 180 minus beta, we have beta r equals beta minus 180. So sort of like the opposite of what we have in 2. And over in the fourth quadrant, we have something over here, and our angle looks like that. This is our beta. Well, now our reference angle finishes off the circle. Okay. Well, we know how to finish off a circle from finding our coterminal angles. It's going to be beta r equals 360 minus beta. It's important that these are only going to work if it's positive, because if we have negative numbers, like if we imagine talking about this angle. What's new color? It's yellow. This angle, that's negative because it's going clockwise. That's in the fourth quadrant. But if this is like 40 degrees or something, then we're going to have a beta R of 400, and that can't possibly be right because all of our reference angles have to be negative 40 degrees, have to be acute, which means less than 90. So this is only going to work if we have a positive angle. If we have a negative angle, you're going to have to reduce by 360s before you can get to what you need. That should be all set. We're going to do the independent practice in class. So have a great weekend. Be kind to each other and make good choices.